All right, so AI is making this huge leap, right? It's moving from just talking to actually doing. And in this explainer, we're going to unpack the core problems and the brilliant solutions behind what's called Agentic AI. This is the tech that lets AI take real action in the digital world. So let's get right into it. So, you've probably noticed this, right? The term AI agent is just suddenly everywhere. But what's really going on? What's changed? And why is this one idea grabbing the attention of, well, basically everyone, from developers all the way up to the C-suite? Well, here's the absolute key. It's because they don't just answer your questions, they actually take action. See, unlike the chatbots we're all used to, which, just give you information, an agent is designed to be a doer. It can interact with software, use different tools, and actually complete tasks for you in the digital world. That is the real game changer here. Okay, so to really get how they do this, we've got to look under the hood at the fundamental mechanics. How exactly does an AI go from being a chatbot to a thinker and an actor? And this brings us to the first major hurdle. Early versions of these agents had one of two problems. Either they just give you a list of instructions, which honestly isn't that helpful, or they just go off and do something without any explanation, leaving you kind of scratching your head wondering, what just happened? The solution is this really brilliant combination. First up, you have reason and act, or react for short. This basically forces the agent to spell out its logic, its whole thought process, before it does anything. And then you have tool use, which, well, it pretty much gives the agent the keys to the car, letting it actually go and execute those actions all by itself. But, for an agent to act reliably, it really needs two more pieces. The first one is called function calling. You can think of this like a universal translator. It makes sure that when the agent wants to say, book a flight, that request is sent in the perfect technical format that the airline software can actually understand and execute. Then you've got the agent loop. This creates this constant feedback cycle where it acts, then it observes the results, like, hey, did that flight get booked? And then it decides its next move based on that feedback. It's how the agent learns on the fly and adapts. And this is a really key point. As industry expert Offer Mendelovich puts it, building a simple one of these loops, that's one thing. But making it robust, reliable, and safe enough to actually use in the real world, that's where the real engineering challenge is. All right, so our agent can take some basic actions. That's great. But to solve truly complex problems, it needs to get a whole lot smarter. So the question is, how do we upgrade its reasoning power from just taking simple steps to coming up with sophisticated strategies? Well, a really common issue with simple agents is that they tend to rush. They just try to find the absolute quickest path to an answer. And that often leads to shallow or sometimes just plain wrong conclusions. They're just not thinking deeply enough. So the first big breakthrough here was something called chain of thought. And it's a really simple but incredibly powerful idea. You basically prompt the agent to think out loud, to break down its reasoning step by step. Just slowing it down like that, making it go through this deliberate process, it dramatically improves the quality of the answers. But this is where the strategy really starts to evolve. Think about it like this. If chain of thought is like hiking down one single trail, then tree of thought is like sending out a bunch of scouts to explore multiple different trails all at the same time. The agent explores several different reasoning paths in parallel, and then it picks the one that looks like the best bet. Okay, but this leads to a really fascinating question, right? Exploring all those parallel paths is great, but what if a discovery on one of those paths could actually help out one of the other paths? Right now with Tree of Thought, all those insights are totally separate from each other. And this is where Graph of Thought comes in. This is really the cutting edge. It allows the agent to create a whole network of ideas where all those different lines of reasoning can merge, they can branch off, they can inform each other. It's how an agent can finally start to mimic that more creative, non-linear way that we humans solve problems. Okay, so an agent that can reason is obviously really powerful, but, brilliant thoughts are pretty useless if they're just instantly forgotten. To be truly effective, an agent has to have a memory. And it turns out agents really need two kinds of memory. First, there's episodic memory. That's the short-term stuff, like remembering what happened 5 minutes ago. This is what stops the agent from getting stuck in loops or making the same mistake over and over. Then you have semantic memory. This is the long-term stuff. It's where the agent stores key facts and concepts, and it's what allows it to build up real expertise over time. So how does an agent actually learn things that it wasn't originally trained on? Well, that's the job of something called RAG, which stands for Retrieval Augmented Generation. This is what lets an agent search and pull in information from external sources, like your company's private documents, and then use those specific facts in its reasoning. This is absolutely crucial for grounding the agent in reality. And this gets even more sophisticated. You have techniques like context selection, which acts like a smart filter, helping the agent find that one needle of information in a giant haystack. And then GraphRag takes it another step further. It doesn't just read the documents, it actually understands the relationships between the documents. So it would know, for instance, that Project Titan is directly linked to the Q3 budget report. All right, we've built an agent that can think, it can act, and it can remember. Now we get to the final, and maybe the hardest part of all. How do we actually put these agents to work safely and effectively out in the real world? See, a single agent can't do everything on its own. It needs a whole support system. First, you have delegation. This is when a main agent can hand off a specific task to another, more specialized agent. Then there's orchestration. You can think of this as the project manager or maybe the air traffic controller that coordinates all the different tools and agents and results to keep everything in sync. And finally, and this one is critical, you have safety guardrails. These set the absolute clear boundaries for behavior to make sure everything it does is safe and governed. Now, I want you to just look at this number for a second. 45%. What do you think that could possibly be referring to? Well, here's the context, again, from Ofer Mendelevich. It means that nearly half of all enterprises trying to build agents will struggle to actually get them working. They'll get stuck at the prototype stage. And why? Because they're missing those crucial governance and infrastructure pieces, things like orchestration and safety guardrails that you absolutely need to turn a cool demo into a reliable production-grade product. And this really illustrates the core challenge perfectly. Trying to just stitch all of these different pieces together one by one, it's slow, it's unstable. What enterprises really need is an end-to-end unified platform, basically an agent operating system that's designed to handle all of this from the get-go and avoid all those common pitfalls. So that leaves us with a pretty big final thought. Maybe the next great leap for AI won't just be another even bigger language model. Maybe, just maybe, it'll be the creation of a true operating system for agents, a system that finally lets these incredibly powerful tools go to work for us safely and at a massive scale. What do you think?